Hello and welcome guys. So in the last video we have discussed about big data. We have seen about what is big data and what is Amazon Redshift, and also we have seen the key difference between data warehouse and data lake. And in this video we will talk about architecture of Amazon Redshift, and also we'll see the difference between Amazon Redshift and PostgreSQL. So this is the Amazon Redshift system architecture. So here if you see, it's a JDBC, ODBC, it's a driver used to communicate with your Amazon Redshift, and this is a Amazon Redshift, and inside this is a leader node, and this is a bunch of compute node, and this is a Redshift managed storage, and this is Amazon S3, which is our data lake, and this is Amazon SageMaker, which is used to perform some machine learning tasks by communicating with Amazon Redshift, and to perform some data ingestion or to query over live data we will use this operational database. We'll discuss about everything in detail, and this data API, whatever query we are executing, so we will get back using this data API. Okay, now first let's discuss about leader node and compute node. What is leader node? So leader node manages communication with client program and compute node. So what is this? Suppose you're querying over Redshift, so you will pass your query and your query will go to Redshift via this bridge, which is your JDBC ODBC. This is you can think of it like a bridge which is used to communicate with your Redshift. So your query will go via this JDBC ODBC and it goes to leader node first. So leader node manage all the queries which you are giving to Amazon Redshift. Okay, and it parse and develop an execution plan to carry out database operation. It takes your query and it makes the execution plan how it can execute your query. Okay, so it develops an execution plan, and then what it will do, the leader node compiles code, distributes the compile code to compute node and assign a portion of data to each compute node. Okay, step 1, leader will take your query, and step 2, it will parse your query and develop an execution plan, and in step 3 it will compile your query and distribute the compile code to compute node. Here is the compute node, here is all compute node. So from here it will take your query and it will make an execution plan, and then it will compile your query and divide your task in some smaller tasks, and it will distribute each task to each compute node. Okay, so this is what leader node do. What is compute node? So the leader node compiles code for individual element of execution plan. So whatever task is assigned to compute node will execute that task only. Okay, that's the work of your compute node. So the leader node compile code for individual element of the execution plan and assign the code to individual compute node, and each compute node has its own dedicated CPU and memory. Also we can increase the compute capacity by increasing the number of nodes and upgrading the node type. This node type is basically the dedicated CPU and memory for each compute node. You can think of it like it's a data type of compute node. Okay, so we can upgrade our compute node based on our use case. So this is all about compute node. If we summarize what is leader node and compute node, then let's see this diagram first. Suppose you are giving some query that select employee number from the employee table. Okay, you are giving this query, so it will go from here, this JDBC ODBC, and it will go to leader node. So leader node will take your query, it will make a execution plan. Also it will divide your query in small chunks, and it will give small tasks to each compute node to perform its operation, and compute node will take its task from leader node and it will perform its task and give back to leader node. Okay, so similarly all compute node will do, and then leader node will take all the tasks performed by compute node, it will combine execution done by compute node and then give back to user via this data API. That's the work of leader node and compute node. Now we will see what is Redshift managed storage. This thing, what is this? So data warehouse data is stored in a separate storage tier, Redshift managed storage. Whatever data is stored in the data warehouse, which is Amazon Redshift, is actually stored in Redshift managed storage. And also Redshift managed storage provide the ability to scale your storage to petabytes using Amazon S3 storage. We can also scale our storage, we can also increase our storage using our data lake, which is Amazon S3. And Redshift managed storage allows you to scale and pay for compute and storage independently. According to our use case, we can increase or decrease our cluster based on our need. Suppose we have some small operation, so we don't need to make a very big cluster and perform that task. We are using a lot of resources, so we have to optimize our resources also. So based on our use case, we will define our cluster and perform our task. Okay, so that's the Redshift managed storage. And as I already explained little about this JDBC, ODBC. So ODBC is Open Database Connectivity, is a C programming interface that make it possible for application to access data from a variety of database management system. So it is a interface which is written in C programming. It makes all the application to access data warehouse which can support this ODBC. It's a bridge which is used to communicate your app. Suppose you want to communicate your app with Redshift, then you can use this ODBC. Okay, any third-party app which support ODBC can use ODBC to communicate with your data warehouse. And Amazon Redshift ODBC is a powerful tool that allow you to connect with live Amazon Redshift data directly from any application that support ODBC connectivity. So any application which support ODBC driver can be used to communicate with your Amazon Redshift. And JDBC is a Java database connectivity, is a Java API that developer use to connect their application to relational database. So JDBC is also a type of connector which is used to communicate with your data warehouse. It's a Java API which developer use to communicate their application to database. So suppose you are making any application, so you can use this Java API to communicate your application with Amazon Redshift. So this is two drivers which is frequently used to communicate your application with Amazon Redshift. It's a bridge between user or application with your database. Now we will see the difference between Amazon Redshift and PostgreSQL. Amazon Redshift is basically built on the top of PostgreSQL. So Amazon Redshift is specifically designed for online analytic processing and business intelligence application, which require complex queries against large data set. As I already explained that it's a data warehouse, so it will hold a very large amount of data, large size of data. So Amazon Redshift is designed in such a way that it can perform complex query against large data set, whereas Postgres is designed for small data set. We can write some simple SQL operation and we will create some small SQL. So to perform that operation we will use Postgres. But if we want to perform some complex query against very large data set, then we will go with Amazon Redshift. And also Postgres is open source, whereas Amazon Redshift is paid service. And this second point is very important. Amazon Redshift store data in columns using specialized data compression encoding for optimum memory usage and disk IO, whereas Postgres uses row ordered approach to build table. Suppose we want to build any table, so this PostgreSQL use row ordered approach to build table, which will take a lot of time to build table, whereas Amazon Redshift uses column order approach to build table. And also they use some specialized data compression encoding technique for optimum memory usage, which will help to optimize your query execution. And PostgreSQL 9.x includes some features that are not supported in Amazon Redshift. We will talk about some data type and function which is not being supported in Amazon Redshift. So Postgres is also have some feature which is not supported in Amazon Redshift. And Redshift operates on cluster, whereas Postgres which runs on single node. So as I already told you here, that Redshift has a bunch of cluster, individual cluster perform its task, and so that we perform it parallelly, which will optimize our work. It will perform fast query execution against large data set, whereas your Postgres runs on single node, so it has single memory, whereas in Redshift each compute node has its own memory and CPU. Okay, so that's why Redshift is faster as compared to Postgres. So this is the key difference between Amazon Redshift and PostgreSQL. And these are some of the list of data type which is supported in PostgreSQL, but it is not supported in Amazon Redshift, like this arrays, bit varying, composite types, date, time types, interval, enumerated types, geometric types, HStore, JSON, network address type, numeric type like serial, big serial, small serial, money, pseudo type, range type, object identifier types. These are some data type which is supported in PostgreSQL, but it is not supported in Amazon Redshift. And these are some PostgreSQL functions, inbuilt function which is supported in PostgreSQL, but it is not supported in Amazon Redshift. Like this every XML, correlation, covariance, these are the list of function, advisory lock function, access privilege inquiry function, array function and operators, backup control functions. These are some list of function which is supported in PostgreSQL, but it is not supported in Amazon Redshift. So that's all about this. So in previous video we have seen big data, Amazon Redshift, what is Amazon Redshift, and what is the key difference between data warehouse and data lake. And now in this video we have seen the architecture and Amazon Redshift SQL versus PostgreSQL. What is the difference between Amazon Redshift and PostgreSQL? So we have done up to this. In the next video we will talk about loading and unloading. So this is very frequent operation used in any big data company. So if you go in any big data company, then you will see this two operation which is frequently done. If your aim is to be a data engineer or data scientist, then you have to be familiar with this two technique. What is this? So what is this technique and how we can execute this? We will also talk about copy command. So everything we will discuss in detail in part 3 of this video. So that's all for this video. We will meet in next video. Thank you guys. Thanks a lot for watching this video.